Hello, grade 11s. In today's lesson, we're going to be looking at vectors in 2D, tackling exam type questions, part 2. And let's see the question that we got. Now we have question 2. It says, four forces A, B, C, and D act as a common point as shown in the diagram below. The magnitudes of forces are as follows. A is 5 Newton, force B is 8 Newton, force C is 6 Newton, and force D has an unknown magnitude. Now we can see all that in our diagram. 2.1 says define resultant vector. What is a resultant vector? A resultant vector is a single vector that has the same effect as two or more vectors acting together. Now 2.2 says calculate the magnitude of the resultant force of force B and force C, right? So for force B and force C, we can see they're all acting horizontally in opposite directions. So for our F net, we're going to have the force of B plus the force of C. But remember, since they're acting in opposite directions, we have to indicate the signs. So we're going to choose positive for the right and then negative for left, right? So now that means what is our force B? It's going to be -8. Remember, the negative indicates that it's acting in the opposite direction to our positive direction. The -8 plus 6, now we have, that gives us -2 Newton. That means our magnitude is 2 newtons. Remember, the magnitude doesn't include the direction. The negative there is indicating the direction. Therefore, after calculating, we have to then write, therefore, the magnitude is 2 newtons. Nice. Now, we have the question that says, a statement that says the net horizontal component for the forces FA, FB, FC, and FD is equals to 1.25 Newton. So we are given what? The net horizontal components, right? So now, since we are given the net horizontal components, we will try to resolve this, try to draw a vector diagram of the resolved forces in here so that we can see all the horizontal forces. Then we have our FB here. We have our FC going that way. And then if we resolve force A, we're going to have our horizontal component going that way. So let's call it FXA. And then we have our vertical component going all the way up there. That's FYA. Now let's try to resolve force D. So we have our vertical component going all the way down. We're going to call it FYD. But what about our horizontal component? Our horizontal component will go to the right. Then this is FXD, right? So in this way we have resolved, but remember, we are looking for the net. We've been given the net horizontal. So that means we are only focusing on this part, right? The horizontal forces. Now let's try to calculate that. We are looking for force D. So let's use the information that we got there. So we go sum of all horizontal forces. We have force B plus force C plus force A plus force D, right? But then remember, we've been given the net horizontal to be 1.25. Then what was FB plus FC? Remember, we calculated in the previous question and we got -2. Then we're going to have plus, what is FAX? FAX, that's 5 but then it's acting in the opposite direction. So we're gonna have -5 cos. Now let's look at the angle. Now you will note one thing about the angle here. We've been given 150 here, but then this is not the angle that we are looking for FA. Remember, the angle has to come from the x-axis in the same quadrant that the force is in, right? So you can see that this 150 is coming all the way from the first quadrant to the second quadrant. Therefore, we have to reduce it to this angle in here. Now you will remember that all this part here, this is an angle in a straight line, which gives us 180. So if we are looking for the angle here, we're just going to have to say angles in a straight line is 180 minus the angle that we've been provided with there. That's 150. So we get 30 degrees. So that's the angle that we're going to use there. Now for force D, also for force D, there is a problem with our angle. Our angle is in between the y-axis and force D. Remember, our angle must always come from the x-axis to the force. So that means we have to consider reducing it again. Now you will remember that the angle in here is 90 degrees. So if we're looking for the angle in here, we have to say 90 degrees minus 30 degrees. Now we're going to have 60 degrees. So 60 degrees for force D and 30 degrees for force A. Now let's continue with our solution. Now we have 5 cos 30 degrees, -5 cos 30 degrees, plus FD cos 60 degrees. Right. Now, solving this, we're going to have 1.25 equals to -6.33 plus this gives us 0.5 FD. Now if we take this, transpose it to the other side, we're going to have 7.58 equals to 0.5 FD. Divide both sides by 0.5, 0.5. Now our FD equal 15.16 newtons. And that's how you arrive to that answer. Now let's continue. Here we are given 2.4. It says, hence, calculate the magnitude of the resultant force acting at point O. Now you will remember that when we calculate the magnitude of the resultant force, we get the net horizontal component and also the net vertical component of the forces, and we add that together using our Pythagoras theorem. Now that we are already given the net horizontal to be 1.25, that means we only need to calculate the net horizontal component and add it to that. So let's do it. Now to calculate the net for the y, we have Ry. But now going back to our diagram, you will see that the only vertical forces we have is the component of y, is the component of A, is the component of A for y, and then also the component of D, right? So that means we have Fya plus Fyd. Now the F that we have for y is 5. Then we have sine 30 degrees. Remember, our angle is now 30. Then plus, remember we got the F, force D, it's negative 15.16 6. Why negative? It's acting downward, so it's in the opposite direction of our positive direction. So we choose this one as positive, then the one that is below will be negative. Then we have sine 60 degrees. Now if we add that together, the answer that we get is negative 10,63 newtons. That indicates that it's 10.63 Newton downwards. Now, let's calculate the resultant. So for the resultant, F net is gonna be Fx net squared plus Fy net squared. So the net horizontal forces and plus the net vertical forces all squared like that. Now we have Fx net is, remember that one we've been given to be 1.25, so it's 1.25 square plus negative 10 plus negative 10.63 and then square. Punch that in your calculator, you have 10.70 newtons. And that's how you calculate that one. Awesome.